Problem number 6 is a problem that's very similar to problem number 5. As always, the first thing that we should do is try to get a graphical representation so that we understand what the problem is asking us to do. We have two curves, y is equal to cosine of x, which is the outer radius in this case, and y is equal to sine of x, which is the inner radius. Both of these functions are being rotated around the line y is equal to -3. The x values that are given, -3 pi over 4 and pi over 4, are both our limits in this case for our integral. The cosine of x is the outer radius, because it is farthest away from the line y is equal to -3, and y equals sine of x is the inner radius, because it is the closest to the line y is equal to -3. Both curves are being rotated around this horizontal line. The shape that's formed is a little bit tricky to try to describe. It's kind of a curved shape with kind of a curved hole in it. I think of something maybe like a vase, but it's also got this giant hole inside the difference between sine of x and y is equal to -3. So how is the integral set up? As always, we start with the outer radius, which is formed by cosine of x, and we need to subtract our line. In this case, the line is y is equal to -3, so we get cosine of x plus 3 squared because of the two negatives. Make sure to multiply by pi. The second part of the volume, the part that we're subtracting away, is formed by integrating sine of x plus 3 squared from -3 pi over 4 to pi over 4. Remember to always subtract your extra volume, particularly the volume that's formed by the inner function, the inner radius. In this case, we're doing inner minus the line because the inner function is the one that's the larger function that's higher up on the y-axis in both cases. Again, we go to our calculator and find out that the answer is 53.315.